Alright, hello Year 9. I'm going to talk through some of the stuff that you did yesterday about the conservation of mass, okay? So what we need to think about is why mass doesn't change in a reaction. So we've talked about the formula masses and we've talked about equations and what happens when a reaction takes place. And we need to think why that leads to the conservation of mass and what that actually means, okay? So I think this was in the PowerPoint that I sent to you. So you've got copper sulfate here in a closed system because there's wire on the top of that conical flask. Now it's reacting with some magnesium and you've got the mass of that as 11.88 grams, okay? Now what will happen is that there will be a reaction and the magnesium and the copper will swap places. So you end up with magnesium sulfate and copper, okay? Now, because there's no bubbles, there is a reaction there, but it's just a swapping reaction, okay? So you'll notice that the mass doesn't actually change, so it's still 11.88 grams, okay? So this is what we mean in terms of conservation of mass. So a reaction has happened, there is a new product, but it hasn't come from nowhere. So when we talked about the word equations, the stuff you end up with has to have been there to begin with, okay? So all you've done is the copper and the magnesium have swapped places. So that means the mass hasn't changed. You have a product, but it was there already, okay? So basically what you need to think about is the fact that atoms in chemical reactions just swap around. They end up in a different order. So this little one here, you've got the red atom and the blue atom. They're going to react together. They're going to join together, but you've still got one red and one blue atom. Now that one joined together will be the product. It will be a different material, but it still consists of one red and one blue atom. Okay, so the mass of everything you start with has to equal the mass at the end because it's exactly the same material that's there, and that's what we mean when we say the conservation of mass. So mass is the same at the beginning as it is at the end. Okay, so for example, you've got your reactants on the left hand side, your products on the right. If we think about carbon dioxide, you've got one carbon atom that's joined together with that pair of oxygen atoms. They rearrange themselves, they make carbon dioxide, which is a different product, it behaves differently, it's a different material, okay? But you've still got exactly the same number of atoms. So whatever they weighed at the beginning, they must also weigh at the end, okay? So one carbon atom plus the pair of oxygen atoms will still add up to the same at the end, okay? Because they've just rearranged themselves. Now, this is the answers to yesterday, okay, so you can check your answers if you didn't send it me. So it just reinforces the idea that things are not created or destroyed, they just get rearranged into the products. Those products might have very, very different properties, but they are still made of the same atoms, and that's what we mean when we talk about conservation of mass. Mass is exactly the same. Okay, so here you've got it sort of on a balance, which is what we think about when we talk about simple equations. Okay, so at the beginning I've got a pair of oxygen atoms. Oxygen is a gas. I've got two pairs of hydrogen atoms. Again, hydrogen is a gas. And on the other side, my product is two molecules of water. So the hydrogen and the oxygen have rearranged, okay, but you've still got exactly the same number of atoms. And you can see that they are quite different because oxygen and hydrogen, the reactants at the beginning, are both gases. Water at the end is a liquid. Okay, so this is what we're talking about when we say conservation of mass. Atoms that you start with are still there at the end. Now, we can think about that in terms of mass. Now, if you look at these calculations, I know it looks a bit tricky because it's lots of numbers and symbols and things, but it's really, really straightforward. So for A, it says there that you've got two pairs, so it relates to the equation before. You've got two pairs of hydrogen, okay, which has a mass of 4, because we've worked that out before, okay? So we know that hydrogen has got a mass of 1, because we've got 4 of them, it's got a mass of 4, okay? My pair of oxygens has got a mass of 32. Now, I haven't made anything new, okay? So all those atoms are still there. So the total mass of the water is the 4 plus the 32. Which gives me 36. So 4 plus 32 on the left hand side is 36, and it is 36 on the right hand side. So the reactants and the products are always the same mass.